Hi there, this is Andy Woodall, the Chief Operating Officer for Simoco Wireless Solutions. I just wanted to show you what we're setting up here in terms of our proof of concept for our immersive tank technology. So I'm just going to go through the room here, the camera angle, and take you through into the room area. So this is the technology that we're working on now around our new Velocity product. What we have here is an immersive tank, and the tank is partially at the moment, which is waiting to go live, is filled with immersive fluid. And as you can see in there already that we have one of the servers from 2CRSI, could equally be a Lenovo or a HP server, that are specially built to actually be servers that can drop into the immersive fluid liquid. And we've also got on the back there, you will see if I just turn the screen around a little bit, you'll see you've got one of the smart intelligent PDUs, which in effect will power up the 12U rack that we have here. So you've got 12 slots for putting 12 different processor cards immersed in the fluid. And then we have the panel, two lots of these panels here will appear as smart intelligent panels to actually drive the power to the servers, but also give us information about what current draw we're getting on each of the independent servers. So the tank itself, as you can see, is a 12U size. It's then connected through to the cooling unit. So what you have here is the control mechanism and cooling unit. So this is the unit that takes out the heat and extracts the heat from the immersive liquid, brings it through a cooling system. On this cooling system, if we wish, on the top here, which we will do, is we'll take this off to something like a radiator, so we can actually take the heat away and make use of that. And we could put that through to radiator, and on bigger installations you could probably possibly take that heat away and actually heat an area or a room. So this is used to extract the heat that's coming out of the immersive chamber itself. All the control mechanism is inside here, and you'll see that what we've actually got is our Velocity unit, and this is the unit now that's doing the smart intelligent operation. And this unit is talking not only to the immersive cooling system and telling us what temperature the liquids are, it's also detecting for us through some of the sensory devices in the corner of the unit here whether the liquid is below a certain rate, and the alarms will go off, as you can hear there. So I'll just reset the alarm. So that's just an indication that the fluid levels have dropped significantly, so we can just basically reset that alarm. So what the Velocity box does, it monitors a lot of the conditions that are coming out the cooling unit and telling us where it is in its processing, what it's doing in terms of the temperatures of the fluid at various parts of it, what the input power details are. So we're collecting that through Velocity as a monitoring system. What we're also using Velocity to do is to talk to the smart intelligent PDU as well. So what we were able to ascertain from here is what current we're drawing externally into this unit to fire it up, into the immersive chamber unit to fire it up, but equally what we're pulling on a current basis against each of the independent slots. We're also, through the Velocity, monitoring some of the things in the room. And if I move over to here to the screen, we've got a screen here which hopefully I can focus in, which shows you all the alarm conditions coming in. So to the left and right, that's the dials and digits here and there. What that currently is simulating is the power consumption happening on the smart intelligent PDU. So this in effect is showing us by server what current and power in watts is being drawn against each of the servers. Then what we have is a graphical representation telling us of what the total consumption of power is that we're pulling into the unit, and what the total output power is as well. So we can start to do what's called a PUE graph to look at the efficiency and the level of efficiency we're pulling in terms of the energy used to actually drive the servers and the energy being used to drive the efficiency of output of power consumption against a traditional data center where it would be air cooled. We've got room temperature monitors as well in the room. So just over on the windowsill here, we've got a Sentry device which is just giving us some indication about the actual room temperature at the moment. And we've also got a door open and door close sensor. So if I actually close the door behind me, what will happen is that Sentry device will indicate that the door has actually been closed, and what you will see in a few seconds is you'll see that door open sensor will actually go into a door closed condition. We can do that through either Bluetooth or Wi-Fi. There you go. So it's just gone door closed. What we can also do is have things like an RFID tag on the door, so we can actually indicate who's in the room through some smart intelligence with some tagging, either through, again, Bluetooth or some form of wireless, that we can actually indicate not only is the door or room open, but we can indicate who's actually inside the room. On the cooling unit itself, which is the box that I indicate just over here, we've also got some of the alarm conditions that we can display here as well. So these are the temperature alarms, coolant alarms, pump speeds, coolant pressure, and again, any indication from there that there's a problem, we can actually bring it up to a visual display. And what we've done there as well is just shown over time the room temperature with a timestamp and also a date stamp. So at the moment, this is our first screen that we're just putting together for a customer. So what we're doing with Velocity is we're doing the alarm monitoring of the system, not only from a room environment, people in the room, temperature of the room, etc. We're going to have a camera that we're mounting in the top corner here, which will be a CCTV camera that we can turn on and actually also monitor who's in the room. And we're going to have a light in here as well, because we're setting this up to be a 24/7 representative proof of concept site. So at the moment, we've got a duplicate site going into Dubai and another one going into Texas, Austin in Texas, and a fourth one going into Melbourne, Australia, where if we're in the middle of the night here, what we can actually do through the console, a similar console in each of the other three sites, is they can switch the light on in this room and switch the CCTV on, and actually we'll be able to see what's going on within here. There'll be a 42-inch monitor going up there, which will take that display and actually show it up on a wall monitor. And we'll also have all the indications of the people involved and all the companies on the wall there, from Simoco Wireless Solutions and all the other technologies and vendors that we're working with to put this technology together. So we're still in the early stages. We're hoping to have this all operational by about the 10th of March. So we've got some more servers coming that we can immerse, hence the reason we haven't fully filled it yet. So we've got all the servers in, and then we'll refill that with all the immersive technology, the coolant. We'll turn the whole unit on. It means this will light up like a Christmas tree, so we'll be able to see all of the power consumption details. We'll have all the alarm monitoring then coming from the device itself, and we'll have the display then, instead of it being simulated as it is at the moment, we'll have all the alarm conditions coming through to it. So I hope that's giving you a little bit of an idea about what we're doing here with the technology. One of the key advantages of the immersive cooling technology is the ability to drive servers at a much higher speed, because we're able to more efficiently cool them. So in a traditional server environment where the servers are sat in racks in a normal data center, what would happen is that the output power and the ability to drive the servers really hard will be the ability to cool the room through a normal air conditioning type of environment. The advantage with the immersive cooling technology is that we're able to take away the heat being created and generated by the servers, take that away very efficiently, cool not only the liquid around and replenish it within the tank itself, but the servers can run a lot hotter than they normally would and actually process more data than they normally would as well. So you get a high level of efficiency, not only in what you're trying to do, whether you're doing CAD rendering or drawings or just running some, high level banking type of transactions, things where you need very high speeds of generating data, but you need to efficiently cool it. Then the immersive technology is becoming one of the key leading examples of how to remove heat from servers, drive them more efficiently, generate more data and more server throughput and power and more applications running on it, whilst increasing your environmental side and efficiencies, because it needs less power to cool. You draw less current, you have less energy issues. We can connect to the device, if need be, a fuel cell, so you might want to run this on solar paneling or batteries, depending where it is. So it creates a very, very efficient and energy saving exercise for customers from running traditional data centers where you may have probably 5 or 6 racks to in effect replicate what we can do in a single 12U immersive tank through data throughput, data speed and with less cost and less servers required to do that, just through the pure efficiency of what we're doing with the immersive cooling technology.